These are the notes for lesson 5.6, the quadratic formula and the discriminant. You may have heard of the quadratic formula before, and this is our fourth and final method for solving quadratic equations. This method will always work regardless of what your quadratic function looks like. So in English, our quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And we're going to talk about how to plug into this formula in this section. So if we look at the quadratic formula, the discriminant comes from what is underneath the square root. And this will help us determine how many solutions we have for our quadratic function. So the b squared minus 4ac we call the discriminant. Again, it determines how many solutions we will have. So how and why does the discriminant work? The discriminant, again, is under the radical. So if we have the square root of a positive number, so if the discriminant is positive, we know that that's going to give us two real solutions. Because when we take the square root of a positive number, we have to look at the positive and the negative. So again, if the discriminant is positive, we get two real solutions. If the discriminant is 0, we know that the square root of 0 is 0, so that will give us one real solution. And lastly, if the discriminant is negative, we know that if there's a negative underneath the radical, that we don't have any real solutions, because we can't take the square root of a negative number. However, it does tell us that we will have two imaginary solutions. So we're going to go ahead and look at examples of each of these. Our first example is 6x squared plus x minus 15 equals 0. So to plug into the quadratic formula, we first need to determine what our a, b, and c values are. And again, these just come from our coefficient. So if you remember, for a quadratic function, the form is ax squared plus bx plus c. So our a in this case is 6 for the coefficient in front of our x squared term. Our b is the coefficient in front of our x, which since we don't have a number, we know that that is 1. And c is just our constant. So notice this is a negative 15 because of the subtraction that's in front of it. Subtraction is the same as adding the opposite, so that's a negative 15. So to find the discriminant, we're just going to plug that into our formula. Remember, our discriminant is b squared minus 4ac. So if we take our b value, that's 1 squared minus 4 times our a is 6 times our c, which is negative 15. So if we multiply this out, we get 361 is our discriminant. We know that is greater than 0, so therefore that tells us that we have two real solutions. So if we solve this, we're going to plug into the quadratic formula. So remember, the quadratic formula is the opposite of b. So in this case, 1 is positive, so it's going to be the opposite of that, which is a negative 1, plus or minus the square root of. Now remember, the discriminant is underneath the square root, so we already found that, which is 361, and it's all over 2 times a, or 2 times 6. So if we simplify this, we get x is equal to negative 1 plus or minus, if we take the square root of 361, that gives us 19, and this is all over 12. So we have negative 1 plus 19, which is positive 18 over 12. 18 twelfths is equal to 3 halves. Or we have negative 1 minus 19, which is negative 20, again over 12, which can simplify to negative 5/3. So our two real solutions are 3 halves and negative 5/3. So if you remember, the graph of a quadratic function, or the solution, is where the graph crosses the x-axis. So in this case, if our solutions are 3 halves and negative 5/3, 3 halves is the same as 1 1/2, so that's going to be right here. Negative 5/3 is negative 1 2/3. So those are the 2 points where the graph is crossing the x-axis, and we can roughly sketch our parabola. So again, on the graph we can see these 2 real solutions as the x-intercepts. So if we have 2 real solutions, it's the 2 points where our graph crosses the x-axis, and when we solve using the quadratic formula, we should end up with 2 real solutions. Our second example is x squared plus 10x plus 25 equals 0. So again, we need to figure out what our a, b, and c values are. Again, they're the coefficients in front of our terms. So x squared, the coefficient is 1, so our a is 1. B, the coefficient is 10, so our b value is 10. And our constant, or c, is 25. So again, to find the discriminant, we are finding b squared minus 4ac. So b squared is going to be 10 squared minus 4 times 1 times 25. We simplify this, we get 100 minus 100, which equals 0. So if the discriminant is 0, again, that means that we are going to have one solution. Remember, that solution is a real solution. So if we solve using the quadratic formula, x equals the opposite of b, so our b is 10, so it's negative 10, plus or minus the square root of 0, all over 2 times a, which is 1. So this is x equals negative 10 over 2, which is negative 5. So x equals negative 5. So as we can see, we got one real solution. Now you might also notice that this can be factored, so we have x squared plus 10x plus 25 equals 0, and that is x plus 5 times x plus 5. So if we solved this, again, we would get x equals negative 5. So again, there's multiple ways that we can use to solve. Factoring would work with this one, but again, the quadratic formula always works as well. So on a graph, again, our x value is where we are crossing the x-axis. So if we go to negative 5, we only have one real solution, so we only have one point where the graph crosses the x-axis. So this is going to be a parabola that sits on the x-axis. And again, we can see our one real solution as that vertex sitting on the x-axis. Our last example on this page is x squared plus 2x plus 5 equals 0. Again, we're going to find the discriminant. So b squared minus 4ac. In this case, we need to figure out a, b, and c. So again, a is the coefficient in front of x squared, so that would be 1. B will be 2, and c will be 5. So if we plug those in, we get 2 squared minus 4 times 1 times 5. We simplify this one, we get 4 minus 20, which equals negative 16. We know that that is less than 0. So that tells us that we are going to have 2 imaginary solutions. We also know that means we have no real solutions. We're going to look at the graph for that as soon as we solve. So to solve, we have x equals the opposite of b plus or minus the square root of negative 16 all over 2 times a, which is just 2. If we simplify, we get negative 2 plus or minus. We know that the square root of negative 16 is the square root of negative 1, which is I. And the square root of 16 is 4, so this is 4I. Again, it's all over 2. Now we can simplify this by splitting it apart. So x equals negative 2 over 2 plus or minus 4I over 2. So we get negative 1 plus or minus 2i. So that's like saying negative 1 plus 2i and negative 1 minus 2i. So that is our 2 imaginary solutions. Now on a graph, if we don't have any real solutions Again, we know that solutions are where our graph crosses the x-axis. So if we have imaginary solutions, that tells us that our parabola is never going to cross the x-axis. So we have no real solutions, so our parabola never crosses the x-axis. So again, if we have two imaginary solutions, our parabola never crosses the x-axis.